Today we're going to be continuing in section 8.3.2. We're going to take another look at area and circumference of circles and see how it applies to a new concept called arcs and sectors. So to begin this, let's take a look at a circle. So here we have a circle and it has a radius of 12. If we wanted to know the area of that circle, we could go back to our handy formula. Area equals pi r squared. If we were to plug in our 12, we could get pi times 12 squared and get 144 pi. This is the area of the entire circle. So what I'm talking about here is the area completely contained inside of the circle. So if I were to color this in completely, the area covered would be about 144 pi. Now, and that would be units squared, whatever it happened to be. Likewise, if we were looking at circumference like this, we could use our formula, circumference equals 2 pi r. Now remember that circumference is the distance all the way around the circle. The area is the entire amount contained within the circle, and the circumference is the distance around it. So we could do the same thing here, and we could plug in our r with 12, and we could solve it to find the distance around the circle. And let's go ahead and do that. So we would have 2 pi times 12, and we would get 24 pi. And that would be units squared. That is the distance all the way around the circle. So our two formulas, very useful, but they have one major limitation. And the limitation is that if we only want to know about part of the circle, they can't really help us. Well, they can, but not in their current form. So, yes, they're great for the whole circle, but now we're going to look at how we can find stuff out about parts of the circle. So before I begin talking about that, I want to identify a few vocabulary terms for you. So let's erase some bits of this. You're already familiar with area and circumference. The two new words that I would like you to learn today are going to be arc length and arc sector. Now, both of these have arc in common. All an arc is a curve of some kind. So in this case, our entire circle all the way around is curved. If we're talking about one part of it, that is our arc. So in this case, between A and B, this here would be called an arc. And just to color it in for you, this right here is the arc. There are many arcs here. This is an arc. If I had another point over here, this would be an arc. Another point here, this would be an arc. And this entire area here, entire distance here, would also be an arc. So basically, when we say arc, all we're talking about is a curved line, a curved part of the circle, a piece of the outside of the circle. The next two terms we have are length and sector. Length is simply referring to how long the arc happens to be. So if we're talking about between A and B, right here, if we're talking about this right here, arc length is asking us how long is it between A and B. Likewise, arc sector is referring to the area contained within that arc. So if we have an arc between A and B, this is the arc length, how long this is. The arc sector is the area inside of that arc, okay, which is contained by it. So to make it a little colorful for you, the arc sector refers to this. It's the area that's just inside this piece of the circle. And that's all we're talking about here. So just this. So if I were to color that in completely, that would be the arc sector. Now, in order to calculate these, we have to modify our previous equations. So if I wanted to know arc length, we're going to use a slightly different equation than we were using before. Remember, length usually refers to circumference. And we know that our circumference formula is 2 pi r. The formula you're going to use for arc length, in this case, would then be this here. For arc length, you would use a formula where you take the central angle. Remember, the central angle is one of the angles in the middle, divided by 360 degrees times 2 pi r. And the reason why this works is because this angle tells us what piece of the entire circle we're talking about, which arc we're identifying, and 2 pi r tells us how long it is. So if we multiply these together, we can find the arc length, which is the distance between 2 points on the outside of the circle. Now, if we're talking about arc sector, it's the same idea. We want to know which piece we're talking about, so we take the central angle divided by 360. But because we're talking about the sector, the area, we're not going to multiply by 2 pi r, we're going to multiply by pi r squared. So to find the arc sector, our formula would then be this right here. So we have two new formulas. They're based on the ones we've already studied. The only new piece of information is that you need to incorporate the central angle to find the area or the length of the arc of that certain piece. Okay, now let's do one quick example. Here we have a circle, and the circle identifies an angle, which is our central angle, and it identifies a radius. If I asked you, what is the arc length between A and B? Okay, so let's say arc length of AB arc. If I wanted to know the arc length of AB, all I would have to do is take my central angle, 60 degrees, divided by 360 degrees, and then multiply it by 2 pi and our radius, which is 12. This would give me the arc length, okay? This would give me the arc length equals this. So that is all you would have to do. Let's take a look at area now. If I wanted to know the arc sector of AB, all you would have to do to find the arc sector is take 60 degrees divided by 360 degrees times pi r squared. And in this case, our r was 12. So, today's lesson is just going to be practicing this. Can you find the arc length and can you find the arc sector? They are related to 2 pi r and pi r squared, but we're talking about pieces now and not the entire circle. So be careful when you read the instructions. Make sure you're finding the right information. Okay. So, the last thing I'm going to leave you with is just the formal equations, and then I'm going to give you some work time. So, once again, arc length we can call it AL if you'd like, equals theta over 360 times 2 pi r. The arc sector, let's call it AS, is equal to theta over 360 times pi r squared. And they are related to area, the area equation we were using earlier, and the circumference we were using earlier. So arc length is related to the circumference. It's related to the circumference. And arc sector is related to the area. In red, we're talking about the whole circle. Red, whole circle. And in black, we're talking about part of the circle. Okay, that's it. Thank you for watching.